Yes, we can start.
Yeah. So good morning, one and all. So next session is on digital twins by Dr. Sunil Shah. Dr. Sunil is the co-founder and CEO of Modelicon Infotech. So he is an entrepreneur with 30 plus years of experience in modeling, simulation, control, optimization, and developing training simulators, etc. And he is basically a chemical engineer with specialization in control and optimization. He holds PhD degree from IIT Bombay in control and optimization, postgraduate certificate in software technology, computer software technology from National Center for Software Technology, and BSc in chemical engineering from NIT Roorkee. I welcome you, sir, for this session. Please, I hand over to you.
Thank you, ma'am. You can see my screen?
Yes, sir.
Okay. And I'm coming out loud and clear also, right?
Yes.
Okay, fine. Great. Cool. Thank you. So first of all, thank you very much, to ma'am, Dr. Rajeshwari Hegde, as well as, BMS College for giving us an opportunity to talk about some of the things that are very near and dear to us, primarily digital twins, and how do we sort of, apply it on sustainable regions, etc. Right. So, what I'm going to do is basically cover first, will I just very quickly give you a background about the company as to what we do in terms of digital twins development and how we do that. Then we'll get on to what really is a digital twin. There are many different avatars of digital twin, so we will talk about some of those and how they are applied in real world. And then we have got a couple of case studies on sustainable solutions and how we are applying digital twins on something which is quite different than what you would have normally come across, especially from sustainable solutions. This is a project actually we are working with in collaboration with European universities. Linköping University. There is there's a there's one for Professor Francesco Casella from Italy, as well as we are just about getting into collaboration with a university in Argentina, primarily trying to look at, how do we sort of, model sustainable solutions, and, and what kind of impact such sustainable solutions will have on each of us, on what is the sustainability of the solutions, how how does it help on the growth, and not only a very local at a city level or it as an individual level, but as the world level. So and how do we build such models, and what does that tell us, is something that I'll try to cover in the case studies that we have. Okay. My request to each of you is, please feel free to sort of interrupt me anytime. If you have any questions, you can either post them in the Q&A chat boxes, or just ping me or give me a call, or no, sorry, just interrupt me and I can we can spend some time on that. Okay. So moving on to what we really do at Modelicon. Yeah, there was a question. Okay. So at Modelicon, we build digital twins for a variety of applications. One of them is just doing modeling and simulation from optimization point of view. So we have done some things like gas gathering stations, where we have like a gas field with multiple wells, and if I want to collect gas from each of these stations and sort of take it to one selling point, how will that model look like? Or for a chemical engineering process, a reactor modeling, steam turbines modeling, battery modeling. So primarily more from optimization, etc. We have also been doing digital twins for batch process operations. So more from control, diagnostics, and performance. We actually do both kind of digital twins. We build something from base engineering principles based modeling, as well as data-driven models. We have also been doing advanced tech and research and development kind of projects. We have been working on UAV control as to, especially when we are looking at very special purpose UAVs, how will you control them? We have been working with, in collaboration with Indian Institute of Science on CO2 systems, especially supercritical CO2, which is used for, sort of generating power. Again, it's a very nice sustainable solution, as well as transcritical CO2, which is basically for refrigeration. Again, something which is mandated over the time, where we start moving away from our current refrigerants, HFCs and HCFCs, the fluorine-based refrigerants, which, as when they leak into the atmosphere, create this whole ozone layer depletion, etc. And so there's this mandate to go green and basically ensure that the refrigerants that we use, whether for our AC or for the chiller or for the refrigerator itself, is a very green solution. So one of the very important refrigerants that we can have is the natural refrigerant, and CO2.
Excuse me, sir.
So yes, please.
Sir, your screen is not to full screen mode.
Okay. I think I'm sharing a different screen. My apologies. Thank you.
Okay, no problem, sir.
Yes, okay. Just let me switch my screens.
Yes, sir.
Okay, good. Okay, please.
Still, it's not full screen.
What are you getting?
I'm getting one slide, which is the current slide, and the next slide on the right-hand side.
Oh, you're getting both. Okay. So,
yeah.
Okay. Just give me a minute. I'll unshare and share.
No problem, sir.
Now it is proper, sir. Just you can put it in slideshow mode, so it will
I
be.
think I think
it's
what I've
proper.
done is by mistake I've shared my. I've not shared the screen. I've shared probably the. Yep. I think this will help. I think I had shared the application, and that was the mistake. So now is it come proper?
Yes, sir.
Okay, good. Yeah, I was sharing the application, so it was basically showing what was in the application. Now I shared the desktop. Okay. Right. So I was at the point of the CO2, CO2 as a refrigerant. So we are working, quite closely with the Indian Institute of Science. And although in India we have got a few CO2 refrigeration plants, in Europe primarily there is a big move, and all the artificial synthetic refrigerants are going out, and people are moving to natural, and one of them being CO2. We of course work on control systems, etc., and use the digital twins for building virtual plants like operator training simulators, or AR VR kind of solutions, especially training. In fact, one of the solutions we delivered to BMS College, in fact to Professor, to ENI department, along with Professor Desai, where we built a whole virtual plant with digital twin and for AR VR application, primarily from training point of view. And then of course, we conduct workshops, FDP trainings, etc. We try to be quite close to the academia, because that is where we get to learn a lot of new things. So ours is primarily a startup. We are about 10 to 15 engineers, chemical, mechanical, E&E, CNI, data analytics. And we provide a wide range of services, more or less on the engineering technology services. Develop digital twins in both first principles as well as data analytics. We do very quick POC solutions for both hardware and software. Provide control optimization solutions to sort of enhance productivity, efficiency, safety of chemical plants. And our focus in industry has been, chemical, petrochemical industry, food and pharma, the electrical and BMS systems, UAVs, and of course, rotating machineries like steam turbines, turbo machineries, engines, etc. So this has been a very quick overview. I'm going to skip this. This gives you a very quick profile of some of the projects that we have worked on. Most of the work, as you would have seen, is on digital twins development. We have just about completed adsorbers, like pressure swing adsorbers. How do you model them? We are using it for some special applications, but of course they can be used for modeling like O2 generators, etc., which sort of are becoming quite interesting and important at this moment. Control and operation of bioreactors, gathering system I already talked about. And so these are some of the projects that we have been working on, building digital twins for different applications. And then of course we build digital twins in sort of AI, ML, data analytics framework, and we do quite a bit of work. And some of the projects are on sort of building prototypes, like for example the CO2 removal system, then BMS system, etc. So this sort of gives you a quick flavor of some of the projects that we have been working on, primarily focused on digital twins. In fact, some of the cartoons that you'll see on the right-hand side is basically a voice-operated UAV that we built for one of the major consortiums in India. Of course, we didn't work on the UAV, but we worked on the control algorithm for that. What you see on is basically a digital twin below of a reactor control system. On the right hand side is the motor control system, which actually we built for BMS college. This is a training, this is a battery management system that we have built to characterize charge discharge cycles of a battery. And what you see in the bottom corner is basically a virtual automation lab, again for BMS, which is basically using AR, VR, along with digital twin to sort of build training modules, etc. I'm going to skip this slide. Okay. Just to give you a flavor of what kind of environments you can use for building digital twins. One of our main our environment is basically a dynamic simulator that we built, and I'll take you through some of the details, not about the environment, but the case study that we have used to build, some of the sustainable solution digital twins. That is Open Modelica. It's one of the languages which has been specially designed for engineered systems. For data analytics, of course, we use R and Python. In case of chemical processes, etc., we use DWSIM. And the main focus is, of course, customized models for that. So from a digital twin point of view, especially if you're looking at hardcore engineering-oriented modeling environment, environments like Modelica, Open Modelica, R, Python are good for you to get started on. Proprietary industrial hardware, where basically most of the time you have to interface all the software that you build onto the hardware. So we use both proprietary as well as open hardware. And of course we build the product services, training modules, etc. So this is some of the contributions that we have with academia. So in fact, on the left hand side, what you see is basically we had a workshop at Adi Shankara Institute of Engineering and Technology in Kochi. Below is in fact you'll see the project, the workshop that we did at the BMS college. In fact, as a digital twin, we sort of tried to build a prototype using Lego Mindstorms, as well as create, so I think it works, okay. As well as ask students to create a digital twin of this so as to sort of control it. So the task of the students for this workshop was to sort of define how do you control this Lego Mindstorm robo such that it reaches the finish line, in minimum time. Okay. We have, of course, been doing quite a bit of, interactions with the students, etc. Showing them, what's a digital twin and how do you use it, etc. So that's a quick overview of, what we do in terms of digital twins at ModelEcon. I wanted to spend some time on that just to give you a flavor of the industrial applications of such an environment, which is not only sustainable, but it covers, from performance point of view, reliability, availability, and safety point of view also. Any questions till now before I jump into digital twins?
No, sir.
Okay, good. So let's get into a bit more detail about digital twin. Why do you really need it? So you need digital twin basically because you want to analyze, study a particular system. It could be, sort of, at a very micro level, operation of an engine in a bus, to operation of a bus, to the operation of a bus on the road, to operation of a fleet of a buses in a city. Okay, how do I sort of, create a model of this, and how do I sort of try to understand, what is the impact that this kind of operation will have on a variety of activities, right? And the simplest, when I'm looking at a smart city and a sustainable solution is, hey, I've got so many buses and I've got so many cars on the road. How is it impacting me as an individual? Okay, it becomes very easy for me to travel, but what are the side effects of that? Is it generating a lot of emissions, which is ultimately impacting my health and the health of my family members and of the community? So how do we sort of, how do we study such an environment? And the reason I gave this example is because the case study that I'm going to talk about is exactly that. And to do that, we basically need to build digital twins. And basically, you need to, so first of all, study a system, right? You can study the system by actually doing experiments on an actual system. But as that is not very tractable, and you can't do a lot of experiments, etc., with physical system from the cost point of view as well as the feasibility point of view. So then you start thinking, okay, hey, instead of doing on the actual system, let me build a model. The model could be a physical system, which is basically a scaled down system of an actual system, which also can be fairly expensive. Or I can think of building an approximate mathematical model, okay, and then use that for sort of studying the system using analytical solutions or simulation systems. Of course, the biggest caveat that you would have here is that mathematical model can never be the full representation of the actual system. And my actual system itself will have many different components. And for you to build a big model is almost, it's not practical from economics as well as time scale point of view. So then you start looking at, hey, what are the things of interest to me, and how do I build models for that? Okay, so and that is one of the components that we'll be talking about. So in fact, that's precise. So if I have a physical asset, I gave you an example of a bus, but what I'm talking about here is basically, showing here is a gas turbine. So that is my physical asset, and I want to build a digital twin for that, right? And the digital twin can basically, like what I was saying, can have different interests. So it can be in terms of finite element analysis model, or it could be a 3D CAD model, or it could be basically I'm trying to look at what kind of failures are happening in this particular physical asset. So build a digital twin which is an FMEA based, or from a maintenance history, operational history, fleet aggregate data. How do I extract that information and sort of build a digital twin, which is nothing but actually a digital representation of my physical asset. And of course, to make it sort of worthwhile, worthwhile, I continuously sort of pick up real-time operational data, sort of sort of put it into my digital twin, and give out information of interest. And the models typically could be physics-based models, statistical models, machine learning, etc. So just to give you, and you would see this with many, as you visit people who make digital twins, you will find that different people will talk about digital twins in a different avatars. So one of them is just looking at the critical parameters. So if you are looking at a digital twin of a car only from a critical parameter point of view, you want to find out how many people are sitting in the car, who's the driver, how many times the accelerator was pressed, how many times the brake was pressed, what's the mileage, what's the temperature inside the car, etc. So those are the critical parameters. You're just basically collecting for a particular car what are the parameters and sort of showing it in a proper way. So basically a visualization digital twin, right? Or it could be a CAD model. So basically, just the 3D model of the car and how it is moving, or how am I designing, etc. So that also is called as a digital twin. Or an FMEA model, which basically talks about how the car operates and how does it fail. Can I use do something on diagnostics point of view? Can I do something on prognostics point of view, right? As to find out when the car will fail, etc. So people will call FMEA based model also as a digital twin. And then you can have a performance digital twin, which is a 1D steady state or dynamic model, or it's more detailed 3D model like a finite element analysis kind of a model. So that is also called as a digital twin. And then of course you have the diagnostics and predictive capabilities. The reason that I really put in this is because depending on whom you're talking to, you will find people talking about digital twin with one-on-one or more of these avatars, right? And depending on what application that individual is looking at, they might have just they might have a visualization screen to show the digital twin, right? So uh, you know so all of this basically is covered in digital twin framework. Okay, so let's why do I really build a digital twin? So let's actually so I have a model. Okay, so I want to look at the digital twin more from operational design point of view. So I can build a digital twin, then I can put it into a simulation environment, start looking at its real-time operation. Here, what you see is a digital twin of multiple tanks operating together, and I want to see how the levels go up and down. Does the level in one of the tanks get depleted, etc. Then, of course, like what I was talking about, visualization and reporting. How are these levels changing with time? Okay. If I want to sort of interface this with an external world, like for example, a control system, etc. So I can use the digital twin. I can, of course, carry out optimization studies, both from design point of view as well as from operation point of view. And whatever hardware that I build, finally, I want to pass it through a complete verification and validation cycle. So again, I can do that with a digital twin, right? So this sort of is, why I need digital twins and how it helps me in different stages of my development and use cycle. So some examples of digital twins. This what you are seeing is a gas turbine model which has been built by Siemens in Modelica. Okay, where you want to sort of figure out, how will a gas turbine behave in case of a power cutoff, right? What is the impact? Like for example, let's say you've got this whole power plant and it is connected to the grid, and for some reason, the grid gets overloaded and the power plant trips, and then what is its impact on the gas turbine? And I want to study that. So again, I can build, a reasonably good, complex, high fidelity model of the gas turbine and then start studying this, right? Or this is a digital twin for optimization, which is for sort of a power distribution, which has been built by ABB using again Modelica framework. Okay. again, build a digital twin and then connect it to the real world and start using it for things like, model-based optimization, etc. Okay. This is a digital twin which is used more from a design point of view for a vehicle, right? So where you build a model of the whole chassis with all the shock absorbers, the wheel. You can actually build the models for the wheel and the road interface, so that you can sort of look at the behavior of the vehicle when it is going through slippery road or going through pothole road, etc. And how does it impact the chassis? How does it impact the engine and the overall behavior, right? So again, quite heavily used in automotive industry, not only from design point of view, but also analysis. And in fact, some of the thoughts that are also going on is, if there's something like, this engine has got what is called as an engine control unit, ECU, okay? And in order to sort of characterize that engine, people would take this vehicle and take it on the road, different types of road, and collect data, and then build the model for the engine, control unit, right? So again, can I build a digital twin for such a setup, and not or reduce my number of experiments that I need to do on the road? This is a digital twin for an aviation application. Again, you basically build a multi degree of freedom model, and then use it for sort of defining your control algorithm. So typically, as you would probably know, that a plane design is inherently unstable design. So it's only the active control which sort of maintains and keeps it flying. So, how do I sort of build a digital twin of the plane and do my control system design there first, and then really implement it in field, right? This is the digital twin for the human body. Okay. So, I can build a sort of, this is actually for, the blood circulation system, the vascular system. So I can build digital twins for different components in the human body, and then look at, how each of them is sort of behaving, and then use this for doing a lot of analysis, etc. This is a digital twin, which is for a power plant, or basically a boiler. Right, so you got a high pressure, intermediate pressure, low pressure boiler, and I got the steam turbines. Okay, so how do I build a combined cycle power plant? Okay, and look at am I delivering the right power? In case there's a fluctuation in the boiler, how is my power plant behaving, etc. So those are the things you can do with a digital twin. Okay, and of course there is one more, which is basically what we have been doing at Modelicon. So I'll just show you a couple of small videos to just give you a flavor on digital twin.
No audio, sir.
Oh, there is no audio. Okay, just 1 minute. Okay, let me just see if I can get the audio on. Any idea? Because I can hear it here. Any idea?
Yeah, you
Okay,
think
Sir,
you have to share sound also. I mean, if it's
sir,
not
go to
shared.
share and choose optimize for motion and video.
Okay. Just give me a minute, please, if you don't mind. What are you seeing at this moment?
Now it is black. That video was playing, but now it's black screen. You can just again select that share and select sound also. That's all.
Yep, okay, got it. Because unfortunately in share, I
Sir.
don't have that option.
Sir, bottom of the screen, you just click on share content.
I'm looking at that. You can see my screen. It is saying share content.
No, next to start video. So there is one share button. Bottom of the screen. Share content.
Actually, for me, it is on the top of the screen. So I'm going to
Okay.
stop sharing this 1 minute. Okay.
Okay.
Yep, I got the share content. Okay, let me start again.
So there, yes, you can select optimize for motion and video.
Okay, got it. Yes.
Yeah.
Okay. We are good. You can see it. So this is basically a digital twin that we have built for an evaporator system. So you have the feed which is coming here. This is a forced circulation evaporator. This is basically for heating.
Sir, you have not shared the content.
I have not shared the.
Yeah.
Then what are you seeing?
It's blank.
Now we don't see anything. It was seen before.
Okay. Yeah, it looks like I'm WebEx challenged. Okay, I think. Okay. Yeah, is it okay now?
Yes, sir.
Great. Okay. So this is the this is the digital twin on the left hand side. Then on the top is the human interface, and then we are interfacing it with the hardware so that you can control the digital twin. this is where you're controlling the level. So it's using the PID controller. So this is, I'll very quickly take you through a hydropower plant digital twin also, where you got a dam with water, then it's going through this penstock, it's going to a turbine, and then you want to basically see how it is controlling. There's no video here, so I'll just there's no audio here. So you're starting the digital twin, and so basically the water is flowing. Now you're going to the turbine operation. So now you can start seeing how the turbine is operating in terms of power. Now you're opening the gate for the turbine. And when you open, that means you'll see that the power value is going up. Okay, this is the percentage opening. Okay. Now you're sort of, you'll close it. Then you're trying to design the surge tank, which is there in a hydro power plant. Now you're sort of creating a disturbance in the grid and seeing how how sort of your hydro power plant behaves. What happens to the surge tank because of the disturbance, right? So these are basically this. So this is a hydropower plant digital twin that we built. I'll just enhance the speed a bit. You want to look at what's the pressure level. Typically, what happens in a hydropower plant is, in case there's a surge, and if you are not designed, then the channel can collapse very easily, because there's huge amount of power pressure fluctuation that can happen here. So this is one important thing that people analyze in a hydropower plant. So yeah, so these are some of the examples of the hydropower plant that and digital twins that we have built over the years. Okay, typically when you're building a digital twin, basically you yourself can take different avatars. You could be a developer, like something like what we do. So we build the digital twins. Okay, or you could be a simulation specialist, like a gamer, right? So who will basically use digital twin and simulate different environments, different scenarios, etc., and try it out. And of course, then there's also a design engineer who will again take the same digital twin and help in designing a system, right? So so as an end user, from an application point of view, there are different avatars that you can have, and people can take a choice as to where they want to get in. But of course, Modelicon primarily focuses on the development part. Okay, so now before we get on to some case studies, any questions? Okay, so let me continue. Yeah, let me continue. Actually, I have a hard stop at 12:30, and I think I'll be able to finish one case study, and the second case study probably Madam, I was thinking of 2:30, but even that might be difficult. I'll schedule some other time with you, and we can do a comfortable. I'll continue with the case study, which is also an interesting case study, especially from a sustainable solution point of view. Okay. So this is a sustainable solution case study that we have been working with Linköping University in Sweden, as well as Open Modelica software, Open Source Modelica Consortium. In fact, main points of contact are Professor Peter Fritzen, Professor Francesco Casella from Italy. Uh, Peter is basically from Sweden, and Adrian Pop is also part of Peter's team. Okay, and from Modelicon also we have a fairly large team. Reshma, Ajaya, Shivam, who have been who are full-time employees of Modelicon working on this project. And then we have about 3 interns, Kaundinya, Manish, and Dinkar, who have just joined, and they're also working on building a digital twin for a sustainable solution. And it's a very, very interesting application I'll talk about. The interns are basically from NIT Trichy. So let me jump into the first, before getting into the case study, just to give you a context, there is this whole environment called as system dynamics. Uh, you know, we have been using system dynamics in Modelica, but this is a concept which is there, since almost about 30 to 40 years. In fact, developed by J. Forrester in the years 1960s and 70s for modeling and simulation mass and information flows for continuous systems, and it is sort of used in soft sciences. Okay, so this is not something which is like a hardcore modeling of a gas turbine, etc., that I was talking about. But this is a very interesting and a different connotation. It's in that sense it's a very low level modeling methodology. So you really don't get into hardcore physics model, but you build sort of simplified models, and the whole environment is powerful not because of the models, but the way you can use these models for a variety of applications. Okay, so system dynamics is a very important field. I don't know how many of you, I'm sure many of you would have gone through this, but for people who have not sort of looked at it before, it's a very, very important field, especially when you want to model systems in life and social sciences, etc. And it is built on these concepts called as levels, which is sort of, which are quantities that can be accumulated, and rates, which are quantities that can increase or decrease the level, right? And and you can think of levels in different forms. So let me actually talk about that. So the levels could be level of population. So if you want to build a system dynamics model for Indian population, so you can build a level where it is population, or it could be money, or it could be what's the level of frustration that a person has, or what kind of low level has. Okay, or if I want to build a model for cancer cells and how the tumor cells are growing and decreasing, then I can build a model levels tumor cells or inventory in a stock. Or it could be knowledge, what is the level of knowledge that a person has, right? So as you can see, huge variety of components that can be modeled. And the level is basically defined by what is the rate. So first point is also, of course, what is the initial level, that is the initial condition in the level. And then there is something what is coming in and what is going out. So for example, population is defined by how many, what's the birth rate and what is the death rate, right? Or money is defined by basically what is the income and what is the expense. Or frustration level is basically what is the level of stress you have and what is the level of affection that you have, right? Or love is basically amount of affection and what is the amount of frustration. If you're looking at tumor cells, then what's the level of infection that you have and what kind of treatment you are doing, right? So basically you can define, and I'll very slowly build it into how it can become very complex, right? Or inventory of a stock is basically what is coming in and what is going out, right? Knowledge, level of knowledge is what you are learning and how much you are forgetting, right? So you might have a particular level of knowledge, and then as you learn, your knowledge increases, and as you start forgetting, it decreases. So what's the level of knowledge that you have, right? So it is defined in terms of d by level by dt is equal to what is coming in minus what is going out. So very simple equation, okay, but can build into a very complex system. Just to give you an idea, So for population, we have got birth rate, right? So birth rate is basically a function of the population itself, right? What is the standard of living that a particular community or that particular country has? What is the quality of food that is being consumed? What is the quantity of food that is being consumed? What is the level of education which is there? And then, of course, are people following birth control, policies, etc. What are the religious beliefs, etc. Right? So the birth rate is dependent on these components, and as you can see, many of these components are levels on their own, in their own sense, right? So birth rate is dependent on population. Population itself is basically a level, okay, or the food quality, food quantity themselves can be levels, right? So what this tells you is that the function which defines the inflow and outflow themselves can be a model on their own right. So just to give you, one example of a system dynamics model, which is sort of a digital twin that you want to build for, let's say, what kind of savings that you have as you sort of grow old with time, right? So the savings basically depends on, what is the income, and the income could be basically, what is the salary you're getting, what is the interest rate, if you are, into share market, what is the kind of dividend you are getting, etc. The expense is basically, function of, how much you are spending, what are your bills, how much rent you're paying, how much taxes you're paying, what is the bank fees, right? And many other things that will come here, right? So that will define, what is the expenses. And then when I build such a model, I can find out how will my savings increase and decrease over time, right? And now what you can do is, now you can use this model to say, hey, what is the impact of my savings with change in interest rate? What is the impact of my savings with salaries? Or, if I move from, low rent house to a higher rent house, how is it impacting my savings, right? So you can see that this sort of builds a system dynamics model, which is sort of a digital twin of your saving, right? And now we can say, okay, now this rent itself is a function of another such model, which could be a function of the area you're staying, and what kind of growth that what kind of population is growing there, what kind of industries coming, what kind of GDP values are there in that particular area, etc. Right? So that will decide the rent. So you can actually you can start quickly imagining that the rent itself comes from a different system dynamics model, or the cost of living can come from a different system dynamics model. So over the time, you can start building more complex connected system dynamics models, right? So let me give you one of the projects that we are working on, which uses this system dynamics model, and which is again connected to sort of the smart city and the sustainable solution that this FDP is about. So this is a transportation hub. We are actually working, like I said before, with Linköping University to start looking at, you know, how does the transportation mechanism sort of impact my day-to-day living. So, vehicle population in a region, whether it's a city, town, state, or a country, as the vehicle population changes, what is the impact that it will have on population, on pollution. And then you can start looking at things like impact of a policy decision. you know if I if in India we say that from 2025 we'll have 20% of all the cars will be on the EVs, electric vehicles, right? So what is that impact that will have on pollution? So I can start building those kind of models, promoting green cars. Or in European country, in Sweden, they have said that in 2025 or 2025 35, no more sale of diesel and petrol cars. So if I stop selling that, what is the impact that will have on my city, right? How do I understand that? Because and there's so many other factors that impact the pollution. So what is that impact of this particular decision will have on the city is what you can use these models for. So, and then of course you can find out what are the key contributors. And then now you can start looking at different scenarios. You can say business as usual. What is happening today is what will happen after 5 years, same growth rate, same buying and selling of petrol cars, diesel cars, what will happen? Or you can say, hey, I'm in a growing country, my growth will be aggressive. What will be its impact on pollution over the time? Or I can say that, as I'm growing, if I start imposing some green mandates, policies, like, more EVs, less petrol cars, what will happen? Or if I can say, if I have a very aggressive green solution, right? I can say that, in next 2 years, no more petrol cars. Then what will that have an impact in terms of my pollution, right? So those are the kind of different scenarios that you can create with this digital twin and use it. So what we have done is we have created a digital twin for vehicles pool. So the vehicle level is basically the number of cars that you'll have of different types. So it could be a car, it could be a truck, it could be a bus, okay? And then you define, at what rate, new cars are being bought or buses are being bought. At what rate the, the cars and buses are going sort of getting out of order, okay? So now you can now decide that, if a car runs for 25 years, what happens? If a car runs for 10 years, what happens? If a car runs for 50 years, what happens? So you can start doing those kind of analysis. So that will give me at any given time number of vehicles that will be there, okay? Then, so this is where I put in the growth rate and the depletion rate logic. So this in some sense is my policy decision, right? As to, if I put in a ban on petrol cars, what will happen? If I say that, I am going to put in a policy such that the EVs are going to increase, number of EVs sales will increase because the customs duty is gone or the GST has been reduced, then what will be the impact, right? So you can basically find out what will be the growth rate and the depletion rates, okay? And then you can create a transportation hub, which will say, I got so many, if I'm taking, let's say, Bangalore. In Bangalore in 2021, how many petrol cars are there, diesel cars are there, plug-in hybrids, electric vehicles, different type of trucks, different type of buses, how much of emission they are generating, and then I can put in this model here for each of these types and find out, how will each of these cars grow over the time, right? So I've sort of created a transportation hub in which I've put in my fleet of cars and defined based on my government policies, based on demand supply situation, as to how this number of cars will grow in Bangalore, right? Then I create what is called as an environment hub, right? In an environment hub, each of these cars will generate pollution. So for example, I'm looking at the total CO2 which is generated, right? So as this number of cars increase and decrease, the amount of CO2 which will be generated in the environment will change, right? So that is basically created using this environment hub. Then I connect my transportation hub to environment hub, right? And now I can use this kind of a model from at a country level or at a state level or at a town, district, city level as to how is this whole transportation situation behaving in terms of emissions, right? So then I can start looking at how are my petrol cars, electric cars, PHV is growing with time. I forgot to put in, but in what is the impact of this in terms of pollution, right? So this is the kind of model that I can create, which is sort of a digital twin of a transportation fleet, at a city level. Or this is what we are trying to do for Sweden, but of course it can be implemented in India also, where you start building, when we say that there's a sustainable solution in place, what is its impact on environment? So those kind of studies can be done here, and then you can carry out sensitivity studies. Actually, I have just 5 more minutes. I'll very quickly cover this, and then I'll give you a flavor of the next model that we'll have. On the similar lines, this is a This is a heating circuit that we have built the model on. So, all of us say that, we have a solar heater on the top of the roof, but what is its impact on, on my consumption? Am I getting hot water all the time? What kind of energy efficiencies can I build, etc. or see? So basically, you build a digital twin of your model where you have hot water storage tank, you have your, house consumer, then you have your cold water storage tank, and you basically create a pattern for your solar heating over the year, and then see what is the impact it will have on your savings, what is the impact it will have on your hot water requirement, etc. Right? I can also sort of, instead of doing it at an individual house, what would be an impact if I have 10 houses together, right? And so for a small community, how it would be. Or so this is where actually, we can sort of create what kind of temperatures will I get, what kind of energy savings which I'll get, etc. in a residential community. Or I can think of, hey, if I have such a system for an industry, what will be its impact, right? Again, all sort of, how do I combine my renewables and and my consumption of my industrial level, my domestic level, to look at what is the impact of such things on a sustainable environment, right? This is where you sort of now integrate an industry and a community, right? A residential, such that initially you supply very hot water to the industry, and then it goes to the community, and then it comes back, right? So what will this have an impact on my sustainable solution, right? Similarly, if I have a power management, if I have a electrical system where I've got photovoltaics, wind, I've got energy storage, I've got my normal grid, I've got my domestic power, I've got charging stations, I've got industry, right? So if as I change my policies, right, as I make my storage cheaper, or as I make more charging stations, what will be my impact in terms of efficiency? What will be my impact of my infrastructure? Will I be able to meet the requirement, the demand? Do I have a lot of surplus? So those kind of situations you can study with this kind of an environment, right? So this is sort of a digital twin at a power plant, right? Let me give you a quick flavor of something which is again very interesting from us, from a global point of view, which is something called as a world tree model, okay, and an earth tree model. So this is again that has been a work which has been going on for last 30, 40 years, okay, where you start looking at a sustainable solution in terms of natural resource depletion, environmental degradation, right? Urbanization. What is over industrialization? What is population explosion? How will all this impact my day-to-day life, right? How does it impact what I'm growing, how much of food I'm producing, how much of what is the impact of the human ecological footprint? What is the impact on human fertility, right? So how do I build a digital twin to sort of look at all this and sort of create, what is the interrelationship that I have for all these components, right? So, as I increase my industrial investment, I need more land. That means my arable land, food production reduces, right? The number of people staying in villages becomes more into cities, right? So how are all these things behaving for the next 50 years? In 2050, will I be able to stay in this world, right? Can I create a digital twin to do that? And people have been doing this for last, so world tree is one model, earth tree is another model. And we have started building these models for us, for our applications. And I'll talk about this in the next session. So I'll stop here because I've got a hard stop. Any quick questions?
Thank you very much, Sunil sir. Yeah, we'll again reconnect because since you also have a lot of things to be told and participants also have a lot of things to be asked. Any quick question as sir has to leave? Any
There's
quick
one
question?
question: how digital twin is developed, tool or language?
So we build our digital twins in Modelica. But people build in Open Modelica or in Python, R. So there is whole variety of modeling environments in which you can build. Some of them are quite drag and drop, easy to build. Some of them, if you are from a developer point of view, you sit down, write down the equations yourself, and sort of put them. So there is this whole set of environments that are available, and we'll talk about it a bit more in the next session. Okay.
Okay. Okay, Sunil sir, thank you very much. So we are again take questions in the next session. We'll have
So we start.
it scheduled
And
and let you know.
Sure, sir. And I definitely want to talk about this world tree and earth tree model, because I think from a sustainable solution point of view, this is something very important for people to be aware of. Is to what are we doing to our earth, and what will be the situation in 2050, right?
Yeah.
Okay, good.
Thank you very
Thank you
much.
very much. Bye, everybody. Yes.
We'll join for the next session afternoon.